All right, let's put some of the pieces together that we've talked about so far in Chapter 2. We're going to try and do a quick sketch of f of x equals 3x to the fourth minus 4x to the third. So we're going to do a couple of things that we've talked about. So first thing is, let's do a lead coefficient test. So on this one, f of x equals 3x to the fourth minus 4x to the third. The only parts that really matter on this one as far as our lead coefficient test are our lead coefficient and the exponent that goes with it. So in this case, our lead coefficient is positive and fourth power is even. So for this one, that's going to tell us positive and even. It's going to give us an end behavior where both sides are going to go up. So that's the first thing that we want to look at. All right, second thing, we want to find our zeros. So we're going to say 0 equals 3x to the fourth minus 4x to the third, and we're going to hit this up by factoring. So on this one, x to the third is all that can come out, and we're left with 3x minus 4. So let's set both of those factors equal to 0. So we can get x to the third equals 0. We can get 3x minus 4 equals 0. So over here, all this is going to get me is x equals 0 with a multiplicity of 3. This one, 3x, is going to equal 4, and divide both sides by 3, and x equals 4/3, which is the same as 1 1/3. So, multiplicity 3. Remember, third power means up, over, and up. Here, multiplicity 1 means straight through. So let's put these two ideas together with our n values and see what we get for our picture. So I know I've got 0, and I know I have 1 1/3. So we're about right there. Now at 0, the multiplicity 3 says it's going to come through all the way with that curve. Well, because my left side, my end point or end behavior is going to be going up, I know that this is going to have to be coming from the top side. So in general, it's going to be coming down, curving, going through, and curving back down. So it's kind of like our upside down third power. Over here at 1 1/3, straight through, and the right end behavior is going up. So I know that this side, it's going to be going this way. So I'm going to end up with something similar to this. It's a little off, but curve back down and curve back up. So it's going to do something like that. Hopefully you'll be able to draw it a little bit neater than what I did, and this will be a little bit straighter on this side. How low does this go? And how steep is this and how steep is this? You're just going to have to plug a few numbers in to our x value up here and get the y value that goes with it. So, but it gives you our general shape. So it went down, it curved, it went down some more, and then it came back up. There, that one's a lot nicer. So that's how we kind of put those ideas together. Our lead coefficient test, tell us what our end behaviors are, get our zeros and any multiplicities, which is going to tell us what kind of behavior it's going to have, and then connect everything with our smooth graph as we go through this one. All right, let's take a look at another one. All right, this time, this will be the equation that we're going to deal with. F of x equals negative 2x to the third plus 6x squared minus 9/2 x. Now this one's a little uglier to work with, but let's still deal with the pieces that we need to do from like that last problem. So our first step is going to be that lead coefficient test. And again, on this one, the main parts that I'm going to need is basically just my first term. So the negative 2x to the third. And again, the only parts I'm looking at, lead coefficient. In this case, it's negative. Exponent that goes with this. And in this case, it's odd. So if it's odd and it's negative, my end behaviors are going to be coming down from the left and going down towards the right. Now this is the part where it gets a little bit nastier on this one just because of the numbers that we're working with. We're still going to find our zeros. So we're going to say 0 equals 2x to the third plus 6x squared minus 9 halves x. Now if you notice, all three terms do have an x in it, so we know we're going to pull out an x. But this one, the thing that's a little trickier is, oops, I should put my negative there. Because of this half, we're going to pull a half out of everything. And the negative that leads, we're going to pull that out as well. So if I do this divided by this, I'm actually going to end up with a value of 4x squared. If I do this divided by this, I'm going to end up with negative 12x. And this divided by this, I'm going to end up with plus 9. And again, I'll leave the math up to you, but it's just taking each of these terms and dividing by this. Now this actually factors one more time into 2x minus 3 times 2x minus 3. So obviously a multiplicity of 2. So if I set these up, negative 1/2 x equals 0, and I can multiply both sides by negative 2, and I'm still going to get x equals 0. Now since it's a multiplicity 1, it's just going to go straight through at x equals 0. And over here I can do 2x minus 3, and again I don't have to do it more than once, it's going to be the same answer both times. Add 3, divide by 2. And there goes our technology again. So add 3, divide by 2, and I get 3/2, or 1.5. And again, since this happened twice, it's a multiplicity of 2. Now again, remember 2 was our touch and turn, just like second power. So let's take a look at this one and see what our picture is going to look like. Or at least our sketch. Again, we're not to the point where we're getting real picky on being perfect with it. Alright, so let's find our points here. So we know 0 is an intercept, so we know that's going to cross here, and we know that 1.5 is an intercept, so it's going to cross here. So let's take a look at them again. Our end behaviors said it was going to go up this way, so we know here that this one's going to just go straight through. On this side, we know it's got end coming down this way, and it's got a touch and turn. So if it's on the bottom here, touch, turn, it's got to turn this way, like an upside down parabola. So we know this one's going to have to go up, touch, turn, come down, turn back around, and go straight through on that side. Now again, this part right here, how low is it? We're just going to have to take some values between 0 and 1.5, plug them into the x's, either up here or in our factored form here, and that's going to tell us how far down this goes and how steep our lines are going to be. But the general shape, you get the idea, looks like that.